Hello everybody, and welcome to your lesson on naming acids. So far we have looked at ionic compounds, how to name them, how to write their formulas, as well as covalent compounds. So today, to wrap up Unit 4, we are looking at how to name acids. So we're going to start off by just the basics and saying what is an acid. So acids are going to be compounds that give off hydrogen ions. So H+, those are cation when dissolved in water. Okay, you guys are probably already familiar with acids when it comes to the pH scale. So if you think back to bio, pH is your potential of hydrogen. Okay, so any solution that's acidic is going to have a pH that's less than 7. So remember the lower end of that pH scale. And this is where that information comes into play. Okay, so we're now looking at it from a chemical standpoint. So acids will always contain one or more hydrogen ions next to an anion. And remember, our anions are non-metallic. They're non-metals. Okay, so we're always going to see a hydrogen with some sort of anion when we're looking at acids. The anion, so not the hydrogen, the anion is going to determine the name of the acid. So whatever non-metallic substance that it is attached to is going to determine the name of our acid. So let's take a look at naming binary acids that do not contain oxygen. Okay, so what we're going to do first, all of these acids will not have oxygen in their formulas. So binary acids contain hydrogen and an anion whose name ends in IDE. So think of chloride, fluoride, sulfide, along those lines. So it's going to end in IDE. So when naming the acid, you have to put the prefix hydro at the beginning. And remember, a prefix comes before. So when we're looking at acids that do not contain oxygen, hydro is going to come at the beginning of the compound name. And then we're going to change the IDE to an IC. So it goes from being an ide to being an ic. And then you add acid at the end to let everyone know, hey, we're dealing with an acid. So let's take a look at an example. We've got hydrogen and we've got chlorine here. Okay, so chlorine is going to be the chloride anion. Okay. So the acid contains the hydrogen ion and the chloride ion. So if we follow our rules, there's no oxygen here. So we know we're going to add the hydro suffix, or prefix, excuse me. We're going to add the hydro prefix, and then that chloride, the IDE, is going to get changed to an ic. Okay? And then we're going to add the acid at the end. So when we're done, what we have here is hydro, chloride becomes chloric acid. Okay, so the name of this acid is hydrochloric acid. Okay, let's look at another example. So here we've got hydrogen attached to sulfur, which is going to be your sulfide anion. Okay, so remember, we know that IDE becomes an IIC, but with sulfur, it's a little bit different. Okay, so we're not going to say sulfic acid. We're going to add a UR as well. Now, there is no oxygen, so we're going to start with the hydro prefix. Okay, so we're going to start with hydrosulfide. Okay, but we don't say sulfic. Okay, so we add a UR. So for the sulfide anion, instead of saying sulfic, we're going to add a UR. And this becomes hydrosulfuric acid. Here's where our UR came into play. So we dropped the IDE from the sulfide. We added the UR, and then we changed the IDE to the IC, and we added the acid. So H2S is hydrosulfuric acid. Okay, so let's name these binary acids. So here we have a hydrogen attached to a fluorine, right? So this is the fluoride anion. If we follow our rules for acids without oxygen, we know we're going to have the prefix hydro. And we want to drop that IDE to make it an IC, so an ic acid. So here we should have hydrofluoric acid. Here we've got H3P, right? So we've got hydrogen attached to a phosphorus, right? So we're going to add the hydro prefix, drop the IDE to an IC, and add the acid. So we're going to have hydrophosphoric acid. Okay, so those were acids that did not contain oxygen. Now what happens if an acid does contain oxygen? There's going to be some different rules that we're going to follow here. So the acid is called a ternary acid if the anion has oxygen in it. So we're looking at acids where hydrogen is attached to oxygen, and these are going to be actually polyatomics. So you guys all have your polyatomics in your reference tables, so you might want to go ahead and get those out and follow along. Also, I posted up common polyatomics in your polyatomic lesson as well. So when we deal with polyatomics that have oxygen, the anion is going to end in an ate, so ATE, or ite, ITE. And again, that can be determined from your common polyatomic reference tables. So if your anion ends in ATE, you're going to change it to an IC. Okay? So if it's a chlorate, you're going to change it to a chloric. Okay? If the suffix on your polyatomic is ITE, so like a chlorite, you're going to change it to OUS. So chlorite becomes chlorus and then acid. You're still adding the acid. Here, when you have acids that have oxygen in it, the hydro prefix is not used. Okay? So if there's oxygen present in the compound, we're not going to have that hydro prefix. You don't have to worry about it. We are still looking at our anion to help us determine what the name of the acid is, but you don't have to use the hydro prefix. Okay? So let's take a look. Here we have HNO3. We have that oxygen present, so we know we're not going to use that hydro prefix, right? So the acid contains the hydrogen ion and the nitrate ion, okay? So this is a nitrate ion. Again, you can find this in your common polyatomic reference table, okay? So you're going to name the polyatomic and change the ATE to IC. So remember, 8 goes to IC. So we're not going to add that hydro in there. We're going to change the ATE to the IC, and we're going to add acid. So this becomes nitric acid, okay? And that's it. There's no hydro in the beginning. So HNO3 is nitric acid. We dropped that ATE, and we turned it to an IC. All right, so here's HNO2. So the acid contains the nitrite ion, okay? Again, you can find that in your polyatomic reference table. So we're going to name the polyatomic again, and we're going to change the ITE to OUS, okay? So 8 becomes ic, ite becomes us, okay? So instead of having nitrite, we will now have nitrous acid, okay? There is oxygen present, so we do not use that hydro prefix, so this is just nitrous acid. Okay, so let's look at this example here. Here we've got a phosphate ion, so ATE, right? And remember, your polyatomic is right here. Your polyatomic ion is the PO4. This is a phosphate. Again, you can get that from your reference table. Because it's an 8, we're going to change it to an IC, right? So this becomes not a phosphate, but a phosphoric acid, okay? So this is phosphoric acid. Okay, so let's do a couple examples. So we're going to name these acids that do not contain oxygen. All right, so here we've got our hydrogen attached to our polyatomic ion. So CO3 is going to be carbonate, right? So ATE. So with the carbonate, we're going to change the ate to ic, okay? So instead of having a carbonate acid, you're going to have a carbonic acid. Carbonic IC, okay? Here, our hydrogen is attached to SO4, right? So this is a sulfate, okay? So again, ending in ATE. If it's a sulfate, we're going to change the ate to ic. But just like with our other sulfide anion, we're going to also add that UR in there. So this becomes sulfuric acid. Okay, again, these contain oxygen, so we're not adding that hydro prefix. Here we've got H2CrO4, right? So this is going to be a chromate, right? So this is a chromate polyatomic. Again, our anion is helping us determine what the name is of these acids. So chromate, ATE, is going to turn to IC, and that's going to be chromic acid, okay? And again, if you're confused about where we're grabbing these polyatomics from, you can find these in your reference tables. Okay, so here we've got ClO2. Now this is not chlorate, this is chlorite. So this is a polyatomic ending in an ITE. And remember, for an ITE, instead of changing it to an ic, we're going to change it to an us. So instead of being a chloric acid, this is a chlorous acid. Okay? So any polyatomic that ends in ITE is going to become an OUS. Okay? And again, these have oxygen in them, so we're not using that hydro prefix. Okay? And that is it on naming acids. If you guys have any questions, let me know. Make sure your notes are in your interactive notebook. We are wrapping up this unit very quickly, so you guys have an assessment coming this week before you start spring break.